the return of the sun after a total eclipse, its rising in the morning after its troublesome absence at night, and the reappearance of the crescent moon after the new moon, all spoke to our ancestors of the possibility of surviving death. Up there in the skies was a metaphor of immortality. Almost 1,000 years ago in the American Southwest, the Anasazi people built a stone temple, an astronomical observatory to mark the longest day of the year. Dawn on that day must have been a joyous occasion, a celebration of the generosity of the sun. They built this ceremonial calendar so that the sun's rays would penetrate a window and enter a particular niche on this day alone. That kind of precision is a triumph of human intelligence. It outlives its creators. Today, this is a lonely place. The Anasazi people are no more. They had learned to predict the changing of the seasons. They could not predict the changing of the climate and the failure of the rains. But their temple continues to catch the sun's first rays on the summer solstice. I imagine the Anasazi people gathered in these pews every June 21st, dressed with feathers and turquoise to celebrate the power of the sun. These upper niches, there are 28 of them, may represent the number of days for the moon to reappear in the same constellation. These people paid a lot of attention to the sun and the moon and the stars. And other devices based on somewhat similar designs can be found in Angkor Wat in Cambodia, Stonehenge in England, Abu Simbel in Egypt, Chichen Itza in Mexico, and in the Great Plains of North America. Now, why did people all over the world go to such great trouble to teach themselves astronomy? It was literally a matter of life and death to be able to predict the seasons. We hunted antelope or buffalo whose migrations ebbed and flowed with the seasons. Fruits and nuts were ready to be picked in sometimes and not in others. When we invented agriculture, we had to take care and sow our seeds and harvest our crops at just the right season. Annual meetings of far-flung nomadic peoples were set for prescribed times. Now, some alleged calendrical devices might be due to chance. For example, the accidental alignment of a window and a niche. But there are other devices wonderfully different. Today, only the dry ruins of the great Anasazi cities have survived the ravages of time. Not far from these ancient cities, in an almost inaccessible location, there is another solstice marker, this one of singular and unmistakable purpose. The deliberate arrangement of 3 great stone slabs allows a sliver of sunlight to pierce the heart of a carved spiral, only at noon on the longest day of the year. The wind whips through the canyons here in the American Southwest, and there's no one to hear it but us. A reminder of the 40,000 generations of thinking men and women who preceded us, about whom we know next to nothing, upon whom our society is based. When our prehistoric ancestors studied the sky after sunset, they observed that some of the stars were not fixed with respect to the constant pattern of the constellations. Instead, 5 of them moved, slowly forward across the sky, then backward for a few months, then forward again, as if they couldn't quite make up their minds. We call them planets, the Greek word for wanderers. These planets presented a profound mystery. The earliest explanation was that they were living beings. How else explain their strange, looping behavior? Later, they were thought to be gods, and then disembodied astrological influences. But the real solution to this particular mystery is that the planets are worlds, that the Earth is one of them, and that they all go around the sun according to precise mathematical laws. This discovery has led directly to our modern global civilization. The merging of imagination with observation produced an exact description of the solar system. Only then could you answer the fundamental question, the one at the root of modern science. What makes it all go? 2,000 years ago, no such question would even have been asked. The prevailing view had then been formulated by Claudius Ptolemy, an Alexandrian astronomer and also the preeminent astrologer of his time. Ptolemy believed that the Earth was at the center of the universe, that the sun and the moon and the planets like Mars went around the Earth. It's the most natural idea in the world. The Earth seems steady, solid, immobile, while we can see the heavenly bodies rising and setting every day. But then, how explain the loop-the-loop motion of the planets in the sky, Mars, for example? This little machine shows Ptolemy's model. The planets were imagined to go around the Earth, attached to perfect crystal spheres, but not attached directly to the spheres, but indirectly through a kind of off-center wheel. The sphere turns, the little wheel rotates, and as seen from the Earth, Mars does its loop-the-loop. This model permitted reasonably accurate predictions of planetary motion, where a planet would be on a given day. Certainly good enough predictions for the precision of measurement in Ptolemy's time and much later. Supported by the Church through the Dark Ages, Ptolemy's model effectively prevented the advance of astronomy for 1,500 years. Finally, in 1543, a quite different explanation of the apparent motion of the planets was published by a Polish cleric named Nicholas Copernicus.